What up, what up? Today we're going to talk about simplifying radical expressions. That is a square root. Now, the method that I use when I do these is pretty simple. It's the way that I use it, which means it's the best way possible. Take whatever number you have and then whatever letter you have and make the prime factorization. Now, if you don't remember how to do the prime factorization, go over here. Let's get a pen going first. Go over here, make yourselves a little factor tree if you need to. 125 is 5 times 25. 5 is prime, circle it. 25 is 5 and 5, circle U, circle U. Rewrite this out and write out the prime factorization of 125n. 125 is 5 times 5 times 5, and then a single n is n. When you simplify roots, if it's a square root, what you're looking for is every identical pair of numbers. I have a pair of 5s. You circle that pair and you bring out one of them. Why? Because the square root of 5 times 5 is 5. And so now you're brought out. Write out what's left over, multiply 5 and n, which is just 5n, and you're done. I just simplified that square root. So let's take a look at this guy. Same exact rules apply. 216, I'm actually not sure what that is off the top of my head. So let's do a factor tree for you. You look like you're divisible by 2. So circle a 2. Let me see, 108. Divide 108. Let's do 4 and 27. I can't circle anything. 27 is going to be 3. Circle that. And 9. 9 is going to be 3 and 3. Circle U. Circle U. 4 is going to be 2 and 2. Circle U, circle U. So I'm going to write out my square root and write out my prime factorization in order. 2, 2, 2, 3, 3, 3, 2 times 2 times 2 times 3 times 3 times 3. And then I'm going to write out 4 Ks. I regret my letter choice, but I'm going with it anyway. All right. This is a square root. So what we're going to do is we're going to look for pairs of identical numbers and pull each of them out. Also, pairs of identical variables. Can't forget them. So let's circle a group of 2s, bring one of them out. 2 is left over. Circle a pair of 3s, bring one of them out. 3 is left over. Circle a pair of Ks, bring one of them out. Circle a pair of Ks, bring one of them out. Nothing left as far as variables go. So what I bring out is a 2 times a 3 times a k times a k. And what I have left inside is a 2 times a 3. Simplify everything. 2 times 3 times k is 6k squared. 2 times 3 is 6. And I just simplified that square root. Pretty easy, huh? I like these. These are fun. I'm having a good time. Another square root. Let me see. 200 is 2 times 100, and 100 is 10 times 10. So we've got 2 times 2 times 2 times 5 times 5. M times M times M times M times N. Circle a pair of 2s, bring it out. Circle a pair of 5s, bring it out. Circle a pair of M's, bring it out. Circle another pair of M's, bring it out. You're left over, so we have 2 times 5 times m times the square root of 2 times n, the leftovers. 2 times 5 is 10. M times M is n squared. The square root of leftovers is 2n. Dunzo. Now, some of you might be thinking, all right, I see what you're doing. You're ripping everything apart. You're showing more work than necessary. I got it. Is there a faster way to do this? Of course. If you see that what's inside here is either a perfect square or something times a perfect square, then just kind of factor out whatever you need to factor out so that you have a perfect square. So 200 is 2 times 100. I know 100 is a perfect square. M to the fourth is also a perfect square, and n doesn't do anything for me. Take the perfect squares and square root them. So the square root of 100 is 10. The square root of m to the fourth is m squared, and then what you have left over is 2n. When I teach it, I always teach it this way. If the numbers get outrageously big, then maybe I'd switch over this way. But, this way didn't take forever. It's not that bad. It's not that bad at all. Let's keep going. Got another square root here. We've got 28, x to the third, y to the third. 28 is 7 times 4, or 2 times 2 times 7. X is x times x times x. That's x to the third, and y to the third is y times y times y. Never make that long enough. 2 times 2 comes out. Boop. X times x comes out. Boop. Y times y comes out. Boop. You have a 2 out here times, 7's left over, and x out here, x is left over, times a y out here, a y is left over. Let's write out those leftovers. 7 times x times y gives me a final answer of 2xy times the square root of 7xy. My goodness, there's already a negative 8 out there. Do the rules change? Absolutely not. Let's keep that negative 8 out there. Okay, and let's see what that is. 24 is 4 times 6, so 2 times 2 times 2 times 3 times k times k times k. Let's bring out a pair of 2's next to that negative 8. No 3's go out. Let's bring out a pair of k's. That goes out too. So on the outside, you now have negative 8 times 2 times k. On the inside, you have a 2 times 3 times k left over. Negative 8 times 2 is negative 16. K comes along for the ride. 2 times 3 is 6, and K comes along for the ride. Not bad, right? This is the last one, and it's still not that bad. We have a number out here, negative 2. Who cares? We have, 3 letters in here. What am I to do? What am I to do? Well, negative 2. Big square root. So that's 6 and 8. So that would be 2, 2, 2, 2, 3. Yep. A, B, 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 C, C. Once again, the line's not long enough. Let's circle groups of 2. Circle it, bring it out. Circle it, bring it out. No 3's, circle a pair of A's, bring it out. No more A's, circle a pair of B's, bring it out. Circle a pair of B's, bring it out. Circle a pair of C's, bring it out. We already have a negative 2 living out there. We're going to bring out another 2, an A, a B, and a C. And what do we have left over? A 3 and an A, so a 3 times an A. Negative 2 times 2 times 2 is negative 8. A, B squared, C, and then what do you have? 3A. So this was focusing on square roots and square roots alone. If it was a cubed root, you'd circle groups of 3 and bring out groups of 3. If it was a fourth root, you'd circle groups of 4 and bring out, one of those. One of those. Thanks for watching. I had fun. I hope you did too. Bye.